All right, hey, what's up, everybody? Welcome to your eighth block math class. It's after school right now, 4:17 p.m. And look it out, check out Infinite Mr. Fortin right here. Oh, sweet, oh, sweet. Okay, so I'm in the Algebra 1 classroom right now. I'm filming this video because I'm going to go through this. I'm going to go through these guys here. You should see it behind me. At least just going to go through part B, I suppose, which is going to be this right here. So you got to do this for homework, right? Keep in mind I can't see myself right now. I have this projected. But anyways, we're checking this one out here. I got to find the exponential function that passes through each of these points here. Okay, so remember we did this through a systems method. Okay, I don't know if you see this here. I'm writing systems here. There are three ways you can solve a system. Okay, maybe flip it over here and you can see it here. Systems can be solved using the equal values method. Okay, also be solved using substitution. And it can be solved using elimination. Those are concepts we studied first semester. Okay, first semester here. So the first thing I want to do is I want to set up a system in this particular kind. We got to be exponential functions. Okay, so here's what I'm working with. I'm working with y equals a times b to the x power. Okay, because we're exponential functions with an asymptote at y equals 0. Okay, and I got these points here. These points I'm going to use to help set up my system. And really, to get my equation, I got to find a, I got to find b. Right, that's it. Like y equals 3 times 5 to the x power. That would be an exponential function. Okay, so I can, if I have my points, I'm going to be able to deduce what a and b have. That's why you're watching this video, because you might want some help with that. Because you know, it is a process. It is a process you kind of have to do. Okay, so check it out. First step, I'm setting up, just getting it all lined up here. I'm going to set up my system. Okay, what is the system again here? Well, when you have one equation, and you have a second equation, it was up there on the back whiteboard. What if they came together? What if we combine them in such a way that we eliminate a variable? Okay, we substitute one thing for a variable, so get rid of it, or we use equal values to set two expressions equal to each other. That also kind of eliminates a variable. Anyways, you'll see what I'm doing in a second. Okay, I'll set up my equation, y equals a times b to the x form, except what I'm doing is I'm replacing the x with 2 and the y with 1.75 in one of my equations. Okay, so my y here is 1.75. Oops. Okay, and the thing I'm deducing, the thing I'm trying to find is what is my starting number? What is my multiplier? I don't know that if I just have 2 points. I don't know what my freaking starting number is. I don't know what my multiplier is. I mean, I could probably figure it out. They're 4 away, so I can take a 4 through. But anyways, I don't want to get too far ahead of myself here. So 1.75 for y, I got 2 for my x. So here, right, I'm just setting it up. And I got some unknowns here, but I know an x and y coordinate would work in the equation that I'm eventually trying to find. Okay, I'm doing the same thing down here. I got a y, I got an x. So where I have y and y equals a times b to the x, I'm going to put 28. And then I'm going to have a, b to the negative 2 power. That's what I'm going to have, okay? First thing I'm going to go through is the method that in block 2. Block 2 I went over, okay, which is the equal values method. Because that's the way the textbook recommended you solve a problem like this here, okay? The ways to do this, equal values method. Step number 1, I want to isolate a, okay? That's what I want to do. I want to isolate a, and I want to do that on both equations, okay? Because once I figure out what a equals, okay, so let's do that on this one. I'm going to isolate a, okay? To isolate a, I can get rid of this b to the negative 2 power. Well, that b to the negative 2 power is multiplied to a, and what gets rid of multiplication? Dividing, right? Dividing. Now, if I have to divide one side by whatever is multiplied to a here, I have to divide the other side by that same amount, keeps my equation balanced, okay? So what I can do is I can isolate a here, okay? And I get this cancels out. I get a is equal to 28 over b to the negative 2 power. Okay, I got that. And that's one of my a's. I can do the same thing up here, right? I can isolate a as well. What am I dividing by this time? Well, b squared is being multiplied to a, so I'm going to divide both sides by b squared. Okay, and I'm going to get 1.75 over b squared is equal to a. Okay, so now I have I've just rewritten my 2 equations that my system setup has, but I have a isolated. Okay, I know a can be represented as this. I know a can be represented as this. So what do I know? Both these things, these 2 things, both equal a. If you're in geometry, this is called the transitive property. 2 things that are each equal to the same thing are equal to each other. So the equal values method tells me these things equal a, So I can set them equal to each other. 1.75 over b squared is equal to 28 over b to the negative 2 power. Okay, b to the negative 2 power. So, next step is, well, I got my b's in the denominator. That's no good, right? That's no good at all because I want to figure out what b equals. B's got to be in my numerator somehow. So I got to figure out how I can numerate it. One thing that I can do is I can remember my laws of exponents rules. If I have a negative exponent, I can take it away, the negative exponent, and move the equivalent thing to the numerator. That might be one thing to do. Why can I do that? Well, I remember I have a rule, which is that anything to the negative power means you just flip the fraction and make the exponent positive. Okay, so that's one thing that you might want to flex on a problem like this. I did. Let's see if you can do it too. Okay. Now I got this here, b squared in the denominator. How can I get rid of that? Well, actually, you know what? I could potentially actually just do the same thing. I make this b to the negative 2 power up there. Sure, I can do that. But what can I do if 1.75 is being divided by b squared? What I can do is I can actually multiply both sides by b squared. I can do that. That's a valid move. Okay. Why? Well, b squared divided by b squared, that equals 1. Okay, so I'm left with 1.75 on the left side of the equation. Here, on the right side of the equation, I have 28 times b squared times by b squared again. And we know that b squared plus b squared, what do you have to do with the exponents? You have to add them, right? You have to add them here. So this equals 28 times b to the 4th power. I told you that we'd have to take a 4th root at some point. We're going to take this 4th root pretty soon, okay? What am I going to do to both sides? I'm going to divide both sides by 1.75. No, I'm not dividing both sides by 1.75. Okay, I'm going to solve. I'm trying to get b, right? Isolate a. Okay, solve for b. Okay, so I'm going to divide both sides by 28. Okay, that's the next step to solving this one here. You might be thinking, whoa, did I do something wrong? No, you're just going to end up with a decimal here. Okay, so let's check this one out. I'm going to grab my calculator, and I'm going to take this 1.75 and divide it by 28. Okay, I get 0.0625. Oh, that's messy. Okay, that's messy, but I'll still do it. I'll move it over here. Okay, I divided both sides by 28. Now I have b to the 4th is equal to 0.0625. So now let me just cross my fingers. I'm going to cross my fingers, and to solve for b here, I got b to the 4th power. What's going to undo that? Well, taking a 4th root, okay, that cancels something to the 4th power. I'll take the 4th root over here. Okay, I'm going to cross my fingers. I'm going to take the 4th root here. Okay, I do this on my fancy iPhone calculator. Okay, so what I'm going to do here is I'm going to do the y root. So I'll put 4 of 0.0625. Is that going to work? Ah, it did work. I got 0.5 there. Okay, 0.5 there. 4th root of this. It's easier to have a scientific calculator, how to take a 4th root. You got to hit the x root button. Say 4 and then x root. And then this number, okay? So now I got 0.5. 0.5 equals b. Ah, I got b. Man, that was a lot of work, wasn't it? Okay, so I got 0.5 for b. That's not going to help me get my equation entirely, but it's going to help me get closer. Because my equation here now is y equals, well, I know I got 0.5, or I have a half. Okay, to the x power. What do I need to do? I need to get a. Well, how can I get a? Well, I have an x coordinate here. I have a y coordinate here. Why don't I use these ones? Because these ones are integers here. -2 and 28. X here is -2. Y here is 28. Check it out. I can use x, y, and I can use b. Those are 3 of the 4 letters that are in my formula, the general form of an exponential function. So if I plug them on in, I should be able to do the work to figure out what a is to reduce it. Okay, I'm changing 0.5 to 1. Okay, I'm doing that because, hey, I have a negative exponent again. Ah, nice. That's going to help me out here. Remember, what does a negative exponent do? Well, it flips the fraction. Okay, so this is equivalent to 28 equals a. 1/2 to the -2 power is the same thing as 2 over 1 to what power? To the 2nd power. Remember, law of negative exponents. Inverts the fraction, and the negative exponent goes away. So here I have 2 over 1. 2 over 1 is the same thing as 2 to the 2nd power. This is pretty easy. We're almost there, guys. Almost there. 2 squared is 4. I get 4a. Divide both sides by 4. Divide both sides by 4. I get 7 equal to a. And voila, we got our answer here. I don't want to just see this as your answer. Come on, guys. Show me your work. working on out when you guys turn your homework tomorrow. My answer here is y equals 7 times 1/2 to the x power, okay? So that was the method that I went through, the equal values method. I went through that with second block. Okay, we have it up here. Lots of work, right? But it's a good challenging problem here. So hopefully you got it. Message me if you didn't. Nice work today, and let me know if you have any questions. I'm gonna make a second video for the approach, which was actually the elimination method that I did successfully go through for third block too. Take care, guys. Bye. Watch the other video if you want to too. Learn a different way to do it, your second block, folks.